Hi, welcome to Road to 100. Here we are looking at a few cons sums and looking at a good approaches of how to solve them in the best possible manner. So sum of all the terms of infinite geometric progression is 14. Sum of the cubes of all the terms of the progression is 392. Now one way of doing it is assume values and see. I know one of the simplest geometric progression, infinite geometric progression, when the ratio is half. There's something we should remember and know. Come the repeated practice and you should know that normally sums are very simple. So if you have that simple things in your mind, it becomes faster to solve. So when the ratio is half for an infinite series, the sum of the terms becomes double of the first term. In which case, if the sum of the terms is 14, I can take first term is 7, 1 minus half will give you 14. And I also realize cube of 7 is 343, very close to 392. So I can use that 343 upon 1 minus cube. The ratio also will become cube. Remember, when all terms become cube, the ratio of the term also will become cube. Solve this 343, 7 upon 8, you get 392. You can see it satisfies. So now we are talking about squares. If it's square, that means the first term becomes 49, 7 square. 1 minus the ratio becomes square 1 by 4. Solve this. So 49 upon 3 by 4. Or you get 196 upon 3, which is none of these. So as I said, one way to do is knowing or substituting simple values and checking out if it satisfies. If it satisfies, you can use that to try to get the answer. Second, A and B have some number of marbles with them, which is less than 25 each. A gives some marbles to B and A will have twice as marble as B. So if you look at A gives some marbles to B and A will have twice as marble as B, so 2:1. And B gives some marble to A, then B will have 5 times this marble to B. So first thing normally I do is I add it up. So A is 2, B is 1 in the first case, 3. So total should be multiple of 3. In the second, A is 5 times of B, to A is 5, B is 1, total should be a multiple of 6. So let me assume if there are 6 marbles, assuming if there are 6 marbles, then A will have twice of B, 4 and 2 after the first exercise, and A will have 5 times of B, that is 5:1 after the second, assuming there are 6 marbles, assuming constant. Now if you look at this comes value after A has given some marbles to B, let's say X, and this comes after B has given some marbles to A, let's say X, right? Which means the difference between 2 and 1 is 2x, so x will be half. The difference between 2 and 1, which is there with marbles with B, here he gets x marbles, therefore it is 2, here he gives x marbles, therefore it is 1. The difference in the marbles with B is 2x, which is 1, so x will be half. That means half marbles are given. Initially A would have 4.5 marbles, B would have 1.5 marbles initially. Okay, initially A would have 4.5 marbles, B would have 1.5 marbles, so basically 3:1. Now check out. I need a total which is a multiple of 6. Also I need the ratio 3:1. Check out the maximum possible case. If I take 24 and 8, the total is not a multiple of 6. Right? If I take 21 and 7, total is not a multiple of 6. I take 24, that's the maximum less than 25. So maximum 18:6, total is a multiple of 6. This satisfies. I mean, maximum marbles with A is 18 initially, so 18 is the answer. Rest of the values don't satisfy. You could form equation and solve, but yes, the maximum minimum is a little bit more complicated. There is no direct answers for it. So you'll have to form an equation, but you'll have to still work on that maximum value and try to solve. There's a very specific way of solving this sum, and this has come in the IPMAT indoor exams quite often. I mean, twice it has come. Somewhere or other, I'm not a direct same sum, but some application of it. They're very simple. The minimum value in such cases when there is equal difference is the middle value. When you take x as a middle value, so here 1 and 200, the middle value is nothing but 100.5. So when you take x as 100.5, right, you will get a minimum value. That's how it works. Maximum value will be when it's in the extreme. So normally a minimum or maximum is either in the extreme case you take or you take the middle value. Same values. That's how it works. So here the minimum comes when it's average 1 plus 200 upon 200.5. If I take 100.5, The first value will become 100.5 minus 1, which is 99.5. Second will become 100.5 minus 2, which is 98.5, and so on till maybe 0.5 when it's 100. Okay, then when it becomes 101, again it becomes 0.5, 1.5, till finally it becomes again 99.5. So basically we are adding 99.5 to 0.5 double time. It's an arithmetic progression. Arithmetic progression is nothing but sum is nothing but first term plus last term upon 2 into number of terms. This is normally what I use for arithmetic progression. Take the average and multiply by n. So you realize 99.5 plus 0.5 upon 2 into number of terms is 100. Right. This becomes 50 into 100 or 5000. And there are two such terms, 5000 plus 5000, the total will become 10,000. If I add to 5000, the total becomes 10,000, that will be the answer. Here you can do LCM method. So there is a filling pipe and emptying pipe. So filling takes 10 hours, emptying takes 15 hours. You can take minus 15. LCM is 30, so filling will do 3 units of work, emptying will do minus 2 units of work. I have to complete this work 30 in 3 hours. That means every hour I have to do 10 units of work. Every hour I have to do 10 units of work. From which there is one filling pipe extra, which is 3 units of work. If I subtract that 3 units of work, the remaining 7 units of work has to be done equally by one filling pipe and one emptying pipe, by filling and emptying pipe. One filling and one emptying pipe does 1 unit of work. To do 7 units of work, you require 7 filling and 7 emptying pipes. So number of emptying pipes will be 7. Number of filling pipes will be 8. Number of emptying pipes will be 7. I repeat, total work 30 to be done in 3 hours, 10 units per hour. From which there is one extra filling pipe removed at 3 units. So 7 units of work to be done by equal number of filling and emptying pipes. One filling and one emptying does 1 unit of work. To do 7 units of work, you require 7 pair of pipes. That means 7 emptying and 7 filling pipes. So from that you get the answer 7. Again, this is again common in CAT where you have 2 variables, 1 equation. So you have number of solutions. A typical way of solving is put one variable with respect to other. Since x is small, x is less than 9, I put y in terms of x. So 1 upon y is equal to 1 upon 9 minus 1 upon x. So I can substitute small values of x and go ahead. If I solve this becomes 9x x minus 9, or y will be equal to 9x upon x minus 9. Now substitute values of 9. I know x has to be more than 9. So if I put x as 10, let's say, out here, I realize that y will become 90. Okay, 10 into 9 becomes 90. 10 minus 1. If I put 11 odd number, but the difference will be even, and 11 minus 9 is 2. 2 doesn't get cancelled with 9 and 9 into 11, so no. Same if I put 10, 11 doesn't satisfy, 10 satisfies, 11 doesn't satisfy. If I put 12, it satisfies, 12 will get cancelled. If I put 12, you will get 9 into 12 upon 12 minus 9, which is 3. You will get y is 36. If I put x is 13, 13 minus 9 is 4, 4 will not get cancelled. X is 14, 14 minus 9 is 5, 5 will not get cancelled to a numerator. There is no 5 in numerator. So 15 minus 9 is 6. But there is no 15 minus 9 6, 6 will not get cancelled because there is no 2 in the numerator. It's 9 into 15, no. Then you will realize next number directly 18 will satisfy. X will be 18 and y will also be 18. From that you can make out 3. Now you can't put more because limit is x is less than y equal to y. So this is the limit. The moment you go further more x, y will reduce. So we need only 3 values. So D option is the answer. Okay. So the way to solve this, again it's common in CAT. You put one variable with respect to the other and then substitute one variable to find out what all values are possible, and you will get the answer accordingly. Okay. Thank you.